So I'll give a short talk, a lightning talk about our open source model that we made at PortfolioEnergy for the Australian national energy market. It's a lightning talk, so it might be quick, but hopefully you can keep up. Just for a bit of context, 2 hours ago, Jorn already gave a talk that sketched it, but for those people that were not there, what exactly am I going to show? So we're focusing on this middle part here in this energy trading stack. So for us, price forecasts are a given, and what we do is we give a schedule as an output. So for the example I'm going to show, a battery, what should the battery do? When should it charge? When should it discharge? We don't do all the other stuff around it. We just do the core part, which we use RTC-Tools for. Also something that Jorn mentioned earlier today is that this open source model that I'm going to show performs really well. So on par with the best performing assets in Australia and New South Wales. So that's something to keep in mind for like how elegant the solution is that I will show you, how well it performs. Well, I can talk to all the mathematics, but I see you see 2 links there that I will. It's a live demo. Quickly show. So one is the read the docs page. So this lightning talk, again, very quick. But in this read the doc page, you can go through the whole example, try to understand it. What is the formulation, and also the code and stuff at your own pace. And of course, if you want to have the code, then go to the GitHub repository, clone it, and run it, which is actually what I'm going to do now. Not clone it, I have it here. And to be completely fair, I will make sure my repository, local repository is clean. So this is a 24 hours horizon, 5-minute time steps. So it's already done. I pressed the button, it's already done. So let's open and take a look at what's happening here. So single battery starts at 50% state of charge. We have a price forecast for 24 hours, 5-minute intervals. Australian market has 5-minute PTU size. I will talk through the code in a little bit, but just to already see what's happening, and if we see happen what we expect would happen. Charging, the red blocks, we expect it to charge when the price is low, right? Cheap price charge. And discharge, so that's the green blocks, when the price is high. So you can see that here, it sees a peak coming, it charges a bit more, then discharges at the peak, etc. So you see that happening. Here at the end, by the way, for those people paying very good attention, why is it charging again at the end, going all the way up? Because for an optimization problem, you would expect it usually to empty at the end. It's because the price is negative. So there's money to be made here. You see this in revenue. There's money to be made just by charging, if you have room, with negative energy prices. So let's jump back into the presentation. This is what I just did. Talk a bit through like how we set this up. So I mentioned we use RTC-Tools to set up this optimization problem. And one of the things we leverage is the industry standard Modelica language to model your physical system. So this is the entire model of the battery. You model your system with ordinary differential equations. You can essentially just, if we ignore this part here and just look at this equation, you can see it takes the derivative of the state of charge, der SOC, is the difference between power in and power out. Of course, there's also efficiencies that come into play, so we take that into account. And for convenience, that I will show in the next slide, for our objectives and our constraints in RTC-Tools, we also define a net power. But this is the entire Modelica model for a battery. Of course, you can imagine you can make much more complicated systems than this, right? If you have multiple batteries or hydropower or rivers or what have you, Modelica is used for the craziest of things to model, so you can all model that and plug it in. Then on the RTC-Tool side, I promise you the code is not much more than this. I think the whole file is 96 lines with a bit of overhead of like import. So this is essentially the code in the RTC-Tools. We define an objective. Now, the objective is also rather straightforward. There's a revenue, net power times price. We have a single price, so that makes that easy. The second term, the cycling penalty you see there, you might not have expected to see that right away. You don't want your battery to cycle even for like very small price differences. You want to, like penalize charging and discharging a little bit, right? You don't want your battery to cycle 3 times a day. So there's a certain cost associated with going from 0 to 100 to 0 again. So that's cycling penalty. So if you take that into account, then you get your objective. And over on the constraint side, a battery cannot charge and discharge at the same time. I had a discussion about this yesterday as well, about how that might happen in some cases. If you don't enforce it, the market can create conditions where this would happen, like essentially like short circuit. So you want to disallow that. And of course, the other 2 constraints here, like this is don't charge beyond your max power and don't discharge beyond your max power. That's essentially the whole optimization problem. Now, the results you already saw. I'm not going to go through them again. One thing I want to mention here, again, almost already done here with lightning talk time. This is a very simple model. This is the current, as I said, like already quite good performance in Australia with the rest of what the rest of the participants are doing. We're going to add bit stacks soon. So bit stacks, and that's this part here. So we're going to probably add that later this year. So if you want to participate in an energy market, you actually have to place bids, like how much energy you want to buy at what price, or how much energy you want to sell at what price. So that's probably something we're going to add later this year. And also this example that I show here is very much for the Australian market. The European markets are slightly different, and probably somewhere early next year, we're going to also release an open source version for that. I focus very much on RTC-Tools with the battery system here. There's also other applications of RTC-Tools in energy world, other than just electricity grids or trading. 2 I want to mention, for those people that know Schiphol, below sea level, Waterschap Rijnland, so the water board there, uses RTC-Tools, has been using it for many years to advise them in pump scheduling and controlling their, I'm not sure how they call this in bosom, but the water system, essentially, like the water level there, to make sure it doesn't flood, and also Schiphol stays operating. And also, yesterday there was a talk on ESDL. For the people that were there, this is a familiar picture, the map editor. And together with TNO and Deltaris, there was projects on design optimization of district heating grids. Using Macedo is what they call the package now, but it is RTC-Tools under the hood for those people that didn't know. So, and with that, I have, well, 1 minute. So thanks. If there's one question in the back. Which model are you talking about? For Modelica model. Currently, I have done other models in the past. Modelica is just very easy because to use as a model language for your physical system, because that's what clients or people have already for simulation purposes. So that's why we leverage it. But it is essentially for RTC-Tools. It doesn't matter where. You can make it such that it comes from other places. Yeah, you can also model in other languages if you want. I have done that yeah. I've made that, so yeah, I know it's possible, but yeah, thanks. All right.